Today we're talking about combinations of functions, meaning I'm going to take multiple functions and put them together. All we're going to do today is add, subtract, multiply, and divide them. Okay? What can you not divide by? 0. That's important. If you're dividing by a function, you must specify the value of x that would make that function 0, because you have to eliminate that from the possible domain. Okay? This is just a matter of combining like terms when it comes to adding and subtracting. Okay? Multiplying is probably going to involve FOIL maybe, or maybe a trinomial times a trinomial, so multiple distribution. Okay? Just like two real numbers can be combined, we can also combine functions. For example, if I had f of x is 2x minus 3 and g of x is x squared minus 1, I could take those two functions, f of x plus g of x, put them together. Here's my f of x function, 2x minus 3. Here's my g of x function, x squared minus 1. Combine like terms, and what do you got? There's an x squared. There's only one 2x. And here we have a -3 plus a -1. -3 plus -1 is -4. That's all there is to that. Okay? Pretty straightforward, I think. If I subtract them, now make sure you pay attention to what the question asks, okay? F of x minus g of x is not the same thing as g of x minus f of x, right? So order is important. So using the same two functions, f of x is 2x minus 3 minus g of x. Notice g of x is in parentheses, okay? The reason that is important is because we're subtracting this entire function, which means that subtract sign is actually going to be distributed, okay? So combining like terms, we have a negative x squared. We only have a 2x term, and then we have a -3 minus -1. -3 minus -1 would be the same thing as -3 plus 1, which is -2, okay? To do the product, they didn't write it out, but all they did was FOIL it, right? This is actually a binomial. 2x minus 3 is a binomial. X squared minus 1 is a binomial. First times first. 2x times x squared is 2x cubed. The next one, let's go ahead and do outside times outside. Spell FOIL correctly. Outside times outside would be a -2x. That's over here. And the reason it's over here is because inside times inside is also -3x squared. X squared has a higher degree than the x term. So you remember talking about standard form? When it's in standard form, the exponents have to decrease. And then, of course, last times last. And then look at the last one, dividing. F of x divided by g of x. So 2x minus 3 is on top. G of x is x squared minus 1 is on the bottom. But you don't just stop there. You have to specify, well, I've got a problem here. Because if I factor the bottom factors into x plus 1 times x minus 1, which leads us to the fact that x cannot be plus or minus 1, because if it was, we'd be dividing by 0, and that's not legal. Questions, comments, anything like that so far? Okay. The domain of an arithmetic combination of functions f and g consists of all real numbers that are common to the domains of f and g. Thinking about, I'm going to go back a slide real quick. If f of x is 2x minus 3, what's the domain? What can x be? Any real number. Looking at g of x, x squared minus 1, what's the domain? X can be any real number, right? So the domain of both of those is all real, which means when we add them together, the domain of those two functions added together is also all real. When subtracting, it's still all real. When multiplying, it's still all real. However, when you throw that, I'm going back to the slide we had just a minute ago. When you're going back to dividing, whatever's in the denominator, you have to throw out any value that makes that part 0. There are different ways of writing this. Instead of writing f of x plus g of x, I could write it as f plus g of x. This is not multiplying, okay? It's not. This is just simply saying I want to add the f and g functions in terms of x. That's what it's saying, okay? Or I want to subtract the g function from the f function in terms of x. Or I want the product of the f and g function in terms of x. Same thing with division. I want the f function divided by g, but these functions are both in terms of x. Have I beat that dead horse pretty good? Okay. No. Thank you. The x is not multiplication. Well, I mean, I could add two functions that were with different variables, I think. Yes. Yeah. Does it have to be functions f and g, or could I add other functions together as well? I could add a b function and a c function, couldn't I? Okay. So here we go. I've got f of x is 2x plus 1. G of x is x squared plus 2x minus 1. Then it says find f plus g of x, then evaluate the sum when x is 3. What this last question is saying, another way of writing this is saying find f plus g of 3. Does that make sense to you? That's their question. Okay, so let's go ahead and find f plus g of x. What that means is we're going to take this f function, 2x plus 1, plus the g function, which is x squared plus 2x minus 1. Now, in the case of adding, now that I've written it down, can I ignore the parentheses? Yeah. Yeah, because I'm adding, the parentheses aren't really doing anything. They're holding what I'm adding together. So the next thing I want to do is combine like terms, starting with the highest degree. So what would be my first term for my answer? X squared. And it's a positive x squared. Next. Okay, I have a 2x plus a 2x, which gives me plus 4x. Next. Negative 1, I'm sorry, positive 1 minus 1 gives me 0. So there's my answer. So f of g, I'm sorry, f plus g of x is equal to x squared plus 4x. So that's the first step of this question. The next step says to evaluate f plus g of 3. All I'm going to do is take the f plus g function and in place of x, put a 3, right? That gives me 3 squared plus 4 times 3. Final answer, 21. We okay today? That was kind of quiet. Matt's absence. Miss you, Matt. Wish you were here. If you watch this later, he won't watch it. All right, guys, that's it for the lesson. I've got a few example problems to work and we're done. What about the other stuff? Huh? Yeah, 2/6 is actually broken up into two pieces. The first piece is adding, subtracting, multiplying, and dividing. The second piece of it is when we take a function of a function, where we take a function and plug it into a function. Everything that I've covered is what's on the test. Okay, we're going to talk about that. I think that's the first thing we do after the test. It's on the syllabus. Tuesday. And then Wednesday, Thursday, and Friday, we'll have 3 more lessons. So we got a busy week. Monday's going to be working on your review and your cheat sheet and asking questions if you have any. Huh? Yeah, that's fine. Okay, so number 1, and y'all are welcome to start working on your homework if that's what you want to do. I'm going to work these problems anyway. So if I was to evaluate f of x equals x plus 3 and g of x equals x squared minus 2, I want to find f plus g of -6. So first thing I'll do is f plus g of x, which is x plus 3 times plus x squared minus 2, which is, combining like terms, x squared plus x plus 1. Now to find f of f plus g of -6, I have -6 squared plus -6 plus 1, which is 31. 31. Okay. Number 2, evaluate the function. It's the same functions, but I want f times g of 8. So I'll start off with f times g of x, which means x plus 3 times x squared minus 2. FOIL that. First times first would be x cubed. Outside times outside is -2x. Inside times inside is plus 3x squared. That's a higher degree, so I'll do the inside times inside, 3x squared. And that outside times outside is -2x. And last times last is -6. No like terms. So now I can compute f times g of 8, which is 8 cubed. That would be 8 cubed is 512, I think. So we got 512 plus 64 times 3 minus 16 minus 8. That's the total answer. So we have 512 plus 192 minus 16 minus 6. Give me an answer. This is trusting someone. Huh? 680? Okay. Do we trust Ty? Did you get the same answer? Okay. And then here's another problem that has 5 parts, kind of like your homework, right? 7 parts. Letter A, we're simply adding the 2 together. So adding f of x and g of x, putting them in descending powers, I've got an x squared plus 2x minus 15. Subtracting g from f. So we would start off with a negative x squared plus 2x. And then we have a 1 minus a negative 16 would be a plus 16, so plus 17. Multiply them. First times first is 2x cubed. Outside times outside is negative 32x. Inside times inside is plus x squared. So plus x squared minus 32x. Last times last, minus 16. And then d, f divided by g of x. The f function is 2x plus 1. Divided by the g function, which is x squared minus 16. I know that x squared minus 16 factors into x plus 4 times x minus 4, which means I would be dividing by 0. If I had an x value, it would be either negative 4 or positive 4. So I'll go ahead and answer letter E. I would like to put that here. And on the homework, I'm not 100% sure how it wants you to do it. I know it asks you what is f divided by g, and I think that's going to be your answer. And then the question after that says, what is the domain of fg using interval notation? Well, if it can't be plus or minus 4, I'm going to go right up here. X cannot be plus or minus 4. It can be anything but positive 4 or negative 4. So using interval notation, negative infinity to negative 4, parentheses, union, negative 4 to positive 4, union, positive 4 to infinity. That would be the domain in interval notation. Those are all parentheses, right? And that is the end of the practice problems for 2-6.